Welcome to Best Math and Science videos, factoring using the distributive property. According to the distributive property, if you have a group of numbers or variables that are added or subtracted, and you multiply the group by another number or variable, you can distribute the multiplication of the number or variable to each term in the group. So 5 times the sum of 2y plus 8 becomes 5 times 2y plus 5 times 8, which multiplied equals 10y plus 40. And you can apply the distributive property in reverse. In algebra, using the distributive property in reverse is called factoring. You start with an expression and determine the largest number divisible by each term of it, in this case 5, and rewrite each term as the product of that number and something else. Then you can rewrite the expression by factoring out the number. You can see how factoring is using the distributive property in reverse. Let's look at some examples. How can you factor 12y minus 16x? The first step is to determine the greatest common factor, the GCF of each term in the expression. Always consider the variables and the numbers separately. So first, look at the variables. These are the letters that represent unknown numbers. The first term has only y, and the second term has only x. The terms have no variables in common, so you can't factor out any variables. But, now look at the numbers. Let's determine whether they have a greatest common factor. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 16 are 1, 2, 4, 8, and 16. What is the greatest common factor? 4. This is the largest number that will divide evenly into 12 and 16. So, step 2 is to rewrite each term using the greatest common factor. I want to pause here for a second and look what we're doing. Since the original expression has 2 terms, I want to rewrite the expression with 2 terms. And notice how I've set up the expression. Each term has the greatest common factor, 4, times something else. Since the original expression has a negative sign, the rewritten expression should also have a negative sign. Okay, so now think. 12y equals 4 times what? 3y. And 16x equals 4 times what? 4x. Now, step 3 is to factor using the distributive property in reverse. Factor out the 4 and multiply it by the remaining parts grouped together. 3y minus 4x. Always be careful to use the correct sign. And that's your answer. Here's another example. How can you factor 36x squared plus 9x? Step 1 is to determine the greatest common factor, the GCF. So, look at the numbers. Since 36 is a multiple of 9, the greatest common factor of the numbers is 9. Now look at the variables. The first term has x squared, and the second term has just x. They have one x in common. So the greatest common factor of the entire expression is 9x. Step 2 is to rewrite each term using the greatest common factor. Then 36x squared equals 9x times what? 4x. And 9x equals 9x times what? Just 1. Now, step 3 is to factor the expression. So you need to factor out the 9x and multiply it by the remaining parts grouped together, 4x plus 1. And that's your answer. Here's another example. How can you factor 10c plus 15c cubed d squared plus 35bc? Again, start by thinking, what is the greatest common factor of the three terms? First, look at the numbers and list their factors. Remember that a factor is any integer that can divide evenly into it. The factors of 10 are 1, 2, 5, and 10. The factors of 15 are 1, 3, 5, and 15. And the factors of 35 are 1, 5, 7, and 35. So the greatest common factor of the numbers is 5. Now look at the variables. The first term has just c, and the second term has c cubed d squared, and the third term has bc. What do these have in common? Just one c. So the greatest common factor of the entire expression is 5c. Now you need to rewrite each term using the greatest common factor. 10c can be written as 5c times what? 2. And the middle term can be written as 5c times what? 3c squared d squared. And the last term can be rewritten as 5c times what? 7b. You can now factor out the 5c and multiply it by the remaining parts grouped together. 2 plus 3c squared d squared plus 7b. And that's your answer. The examples in this video show how to factor trinomials using the distributive property. For more complicated polynomials, watch the related video on factoring by grouping. And you might also be interested in factoring trinomials with a leading coefficient of 1, or with a leading coefficient not equal to 1, or using the difference of squares. Links to these videos are in the description below. And be sure to click below to subscribe to best math and science videos. Thanks for watching. See you next time.